morning. Today our topic is sweep frequency generator. So in the previous class we discussed about the what is the function generator and the signal generator. So function generator, we see that they generate different type of waveform: sinusoidal wave, triangular wave, square waveform, various. And signal generator, we use amplitude modulation, how it is generated. So today the topic sweep frequency generator. So what is the sweep frequency generator? It means a sweep frequency generator or a sweeper is a special type of signal generator in which output frequency is cyclically sweep through a range of frequencies. So there are a range of frequencies where we can cyclically sweep the frequencies. The instrument may have a display built into it so that a variation of amplitude with frequency, or it may be provide a signal for use with a external oscilloscope. So if we draw the basic block diagram of a sweep generator, there are the two axes, x-axis and y-axis. And x-axis we get first frequency sweeper, then frequency control. This control is done by manually. Then the frequency generation, and last was the output attenuator, where we get the output. This is the x-axis for the display. Similarly for the y-axis, if we show, the first one is the adder, then it's go through a amplification and shaping for amplifying factor and shape the signal. Then low pass filter, and again it goes to the mixer. Mixer is frequency generator mixer. Then it is connect to the, if we mixer with using crystal oscillator, we generate the frequency, and then goes to the harmonic generator. So this is the y-axis, the marker generator point we have to see. So from the block diagram, there are the two modes are used for frequency range: stop or start frequency range, means F1 to F2 mode. And the second one in this mode, stop and start frequency, are the set to the front panel, and instruments sweep the between the limits. This mode is used for wide sweep width, means the frequency with wide range then we use. Another mode is the delta frequency mode. What is the delta frequency mode? In delta frequency mode, there are the some maximum exertion of the frequency. So what happened from the set of panel, it is used for narrow band frequency width. The frequency range of the sweep frequency generator usually exceed over the 3 band. There are the 3 band we use for the axis frequency. Number 1 is the 0.001 Hz to 100 kHz for the low frequency to audio, 100 kHz to 1500 MHz for radio frequency, and 1 to 200 GHz for microwave range. These are the cover the wide range of sweep frequency from a single instrument. We can generate manually switching different between the oscillator. There are 3 ways we define manually switching between the different frequency of the, but the problem here is the frequency range needed overlap the two band. Number two is stack switching. In this band, automatically selected electronic switching so that one can sweep the whole instrument range as a one continuous band. And number three is the heterodyne control. What is the heterodyne control? In heterodyne control, two frequencies, high frequency, are mixed. Heterodyne means mixing. So here we mix the two frequency so that we get the heterodyne frequency. So if we see the what is in heterodyne frequency range, there are two are similarly in previous there are x-axis, y-axis. Here are the two frequency generator are used. Frequency generator 1 and another frequency generator 2. So two generator generate the frequency, these are mixed, so the name is heterodyne, means mixing. Then it's go low pass filter, output attenuator, same as previous we see, and goes to the output. And the y-axis there is a mixer generator, mean mixing the frequencies. This goes to the y-axis, and there is the display in the same as previous. And what is the x-axis? X-axis again we see there is the frequency sweeper, and the frequency control, same as previously. Frequency control is done by manually. So output here mixing, there are two frequency are mixing. The function generator, they are mixed heterodyne, means while a range of frequency can be varied, suppose 3 to 5 gigahertz as change, or 2 to 3 first generator, and second generator generate a frequency output of 3 gigahertz. So this may be vary from 1 to 2000 gigahertz range. So tuning is needed for wide output variation for small. Using tuning we can tune the selected frequency. However, the non-linear mixer will produce many other frequencies in addition to the required one. Output level control is used with frequency generator to keep the output amplitude to the set of the one dial. And usually radio frequency detector monitors the RF amplitude of the output. This is combined a single corresponding to the required amplitude, and the error is feedback to the electronic attenuator circuit to keep the output constant. The gratitude of the display we see that is not accurate enough to be able to interpret the frequency being displayed, and some sweep frequency generator have the facility to putting a series of accurately known frequency maker on the scheme. So if we see there are we use maker generator in the previous circuit, here we can use this type of circuit. Heterodyne, the mixer with a sample of radio frequency from the sweeper. The mixer will produce a series of low frequency difference output brush called the sweeper frequency approaches through the harmonic frequency. So if we see there are the frequency sweeper generator, there are the some error is generated. This error is known as sweeper error. So what is sweeper error? Sweeper error, if we see that due to the imperfect of the output of the generator, these error are generated. Any harmonic produced in the frequency should be swept along the fundamental but at a faster rate. For example, if we take the n number of harmonics, so swept will be n times of the rate of the fundamental. So this harmonic may be within the pass band of the device being tested, of the path of the sweep, and the out of the pass for the rest. If we draw the amplitude versus frequency graph for a n x-axis we take the frequency, and y-axis if we take the amplitude. So if we see the graph, this is the graph. here the display filter output, and these are the frequency fundamental sweep. And if we take the innate harmonic, then this is the innate harmonic sweep. So a bump is generated using innate harmonic is present, so several overlapping harmonics are produced since the bumps. So generally only second and third harmonic are under constant, higher harmonic much lower amplitude. The accuracy of the output and the change in the amplitude with the frequency is another important consideration. The amplitude varies with the sweep rate, and since the amplitude feedback correction circuit have less time to work faster sweep rate. So the output of a sweeper is not a linear, which means the spacing between the maker is not unequal. There is no equal. So it can easily estimate the value of the frequency using two makers. Again, from the sweep frequency generator we get the what is happen here. Another topic is frequency synthesizer. What is the frequency synthesizer? If we see the frequency synthesizer, we see that there are two frequency synthesizer in the type. First one is the free running. Free running, what is the meaning of free running? In which output can be considered continuously over a range of frequency range by mechanically or electronic method. These are the types described so far, that there are the good for overall performance and their frequency accuracy and stability are relatively poor. And synthesizer, which has the output derive a fixed frequency high stable oscillator and covers a range of steps. So synthesizer are the two types, direct and the indirect. What is direct and what is the indirect frequency generator synthesizer? Indirect synthesizer use a stable crystal oscillator followed by a series of harmonic multiplier and mixer to provide a range of different output frequencies, and the indirect frequency synthesizer use a phase lock loop to give an output which is a fraction of that of a stable crystal oscillator. The synthesizer technique provides a generator which is excellent frequency accuracy and stability, but the design is careful because the suppressor signal at the output. So if we see the indirect frequency synthesizer, what is the block diagram? First one, the reference frequency. Suppose this is the reference frequency F1, and it goes to phase detector, detect the phase, then low pass filter, then amplifier for then voltage control VCO. We take the NF1 VCO, we can set the frequency, and the frequency programmable N divider. Divided N, so phase detector F1 and the output we get in F1. So what happened here, the basic diagram of frequency here, the output of the phase detector signal produce the signal F1 plus minus F2, means F1 and F2 are mixed, if it is plus or minus. So it's if it is plus it increases, it minus it decreases, F1 plus minus F2. So the low pass filter select the signal and which then amplified and feedback to the voltage control oscillator VCO. The output of the VCO is then passed to the programmable divider and then back to the phase detector, so that the system F2 forward the F1 until they are equal, and the stage there is the phase difference to frequencies produce sufficient DC signal to keep F2 lock with F1. The output frequency is NF1 and thus changed by making the N usually the keyboard from the in front of the instrument. So what is say the switching speed between the frequency synthesizer or the frequency generator depends on the time need to F2 log to F1 and the setting time. For large frequency difference to lock time can be long. This minimize the VCO close to the final value. Usually under microprocessor control, we can control this and letting the phase loop pull its exact value. The setting time is timed after for the output reach with a given final output of the CPU. Typically, it is a few millisecond microsecond. So indirect frequency, the problem is basic. We see the frequency range. The VCO which convert wide frequency range over the programmable divider needs a large divider ratio to noise within the loop bandwidth. So multiple frequency generator can be generated indirect method. So how we multiple frequency generator? Use low frequency synthesizer. If we use low frequency synthesizer, then is passed through a phase detector, then it's passed through a VCO voltage control, then here is the mixer, mix the two frequencies, there is the high frequency synthesizer. So two are mixed here so that a multiple loop frequency synthesizer is overcome the disadvantage of the previous one. So low frequency synthesizer is a small range, it's over a small step. We the high frequency synthesizer over a wide range of frequency. So combining the two frequency, we get a wide range of with small step. So these are the conclusions of the frequency synthesizer and the signal generator we have discussed in the previous class, and the function generator. So from the points we get, there are the sweeper generator which are used for the signal.